All right, EP Stat students, we should have a nice, easy section for you on some things that you should have talked about in mostly your Algebra 1 and maybe some in Algebra 2 classes. So we're going to talk about scatter plots and then correlation. So the National Student Loan Survey provides data on the amount of debt for recent college graduates, their current income, and how stressed they feel about college debt. A sociologist looks at the data with the goal of using amount of debt and income to explain the stress caused by college debt. What are the explanatory and response variables? Well, we already know explanatory and response variables. Explanatory is kind of like your independent variable, and response variable comes from that. So our explanatory variable is going to be our college debt. Our response variable is going to be the stress caused by that college debt. So then we're going to look at some of this stuff. So we took our seated and post-walk pulses, and then we're going to talk about explanatory and response. Well, in this case, it's a little unclear about which one's explanatory and which one's response. So it doesn't always work out perfect, but typically there's an explanatory and a response that's relatively clear. So if we make a scatter plot of this data, we always put the explanatory variable on the horizontal axis and the response variable on the vertical axis, and you must label. We've already talked about this. Notice that there's two different variables. We've been dealing with one variable data for a very long time. So we'll put our seated as our explanatory and our post-walk as our response. And looking at our data, we got 76, 68 to 114. 48 is the smallest. And then our post-walk, we have 56 as our lowest and 130 is our highest. All right, so we'll take our first data point, 76, 86. About there. Then we have 68, 82. Then we have 68, 68. Then we have 114, 130. And then we have 48, 56. So you can see that this looks relatively linear. So to describe a scatter plot, we have to look for these four things. Remember before how we had SOCs for one variable? Well, this is DOFs. Not really a good one, but it does the job. So direction, outliers, form, and strength. Direction would be positive or negative. So we look at ours up here, it's positive, it's going up. Any outliers? It doesn't look like there's any outliers. And when we talk about outliers, we're talking about things that are off the line. So we would be talking about over here and over here. Not necessarily down here because that would be on the line. Form would be the type of graph. This one looks like a line. We could have quadratic, we could have exponential. And then strength is how close are these points on the line? Well, if I drew a line of best fit, these points are all very, very, very close. You can definitely tell it's very linear. So this is very strong correlation. The graphing calculator can also make scatter plots for you. It's fine to sketch the scatter plot from your calculator, but you must label your axes. Okay, we already knew that. So correlation. So this is what a correlation of 0 looks like. You don't really have any sort of lines. This is a correlation of negative 0.3. The negative means that it is going down, right? That's the direction. And then 0.3 means that it's not really very linear. It's pretty low. Correlation of 0.5 is midway. This one's positive because it's going up, but 0.5 is a moderate correlation. So this is a low correlation. I'm talking about the strength. This is no correlation. This is a moderate. This is getting stronger now. It's negative because it's going down. That's the direction. and this is a moderately strong. And this is getting strong, 0.9. You can see how we can see a line kind of forming there. And this is very linear. That's negative 0.99. The negative is the direction. 0.99 is very close to 1. So this is a very strong strength. So you can see how this is getting very strong. It tells us that R has to be between 1 and -1, right? -1 and would be a perfect negative correlation, and 1 would be a perfectly strong positive correlation. This is how it's calculated. You will not need to compute it by hand, but we'll learn more about how to do it at the calculator in the next section. But basically, it's not that tough. You have your individual point, and then how far away it is away from the line in the x direction over the standard deviation of the x's, which makes sense. And then you have the same thing with the y. You have your actual point, how far it is away in the y direction, and then divided by the standard deviation of the y's. So here's some facts. Correlation makes no distinction between response and explanatory variables. So if you switch them, R would stay the same. It does not change when units of measurement change. It has no measurement unit. It requires both variables to be quantitative, right? Remember, not categorical variables. The categorical variables we use their chi-squared test on. It only describes linear relationships, so we can't use R for other things like quadratic or exponential. And it is affected by outliers. So sometimes when we do these correlation things, we ignore outliers so that we get a better value for R. It is not a complete summary of relationships. The mean and standard deviations of both variables are also important, and you're going to see that in the next section.